routers software on your laptop. There's a suite called Zebra that speaks many of the protocols out there. There's some that are proprietary to a given vendor. For example, EIGRP, until fairly recently, was not available in that sort of form, but there's a Perl script that will do that sort of EIGRP manipulation for you, and we'll get to that in the tools slide a little bit later. So one of the key things is that since a more specific route is usually preferred to a less specific route, when people are advertising their aggregate blocks, if you want to steal part of that, you can just inject into their routing protocol, oh, you're advertising the /24? Dude, I totally have that /29. And you will get the route in most places. A lot of this is going to be context particular, but general guidelines, this is worth trying. Now, if you hijack someone's whole subnet, they'll probably notice. So if you're trying to be stealthy, this is not the way to go. They may not know what's going on. It may take them a little bit to figure it out. But if you want to do something just particular as one machine and you can't crack that machine, you can always try getting the subnet, have a machine with that address, send your stuff, get your reply, drop back off. Oh, and suddenly the internet is back. And they don't know what happened, but it's back now. That's okay. And that happens a lot too. A stealthier thing that you can do is if you can map their network and you know what IP space they have, but you can see a block that they are not using but that they own, you can announce that within their internal routing protocol. And because of route redistribution, a fair bit of the time people will take their internal routing protocols and announce that out, or just announce their whole block out. So your block will be just sort of sucked up into that, and you'll have a legitimate block of space within their address space from which you can do whatever you want. There's a really nasty version of this that happened to an American mining company where it wasn't done from within their network, but they had someone join up at another ISP and say that they owned these guys' existing net block. And because of the way that BGP was at the time, they had a lot more pull. So their existing net block went to these other people, and they spammed, they sent a bunch of viruses, and they did a whole bunch of wicked evil stuff. Meanwhile, the people who actually own the net block were like, hey, we'd like our internet back. Why won't anyone route to us? It took a couple of weeks to get it cleaned up. And once they did, they had a whole lot of people ticked off at them for all that spam and all that malware and all that stuff they sent out. And they were on every blacklist on the planet. And their space was basically useless because no one would accept mail from them. Everyone thought they were jerks, and they got a whole lot of hate mail. And, while the global routing community has taken steps to make that harder, it's still possible, and that's really nasty. To make this worse for the, worse for the defender, better for the attacker, a lot of infrastructure devices, if they log at all, they log locally. So assuming that you manage to pop the password on the device, you can just go, hey, clear the log. Oh my God, it's like I've never been hacked at all. And that's all the record they had. So they have no forensics, they have no way to track it. If they do log centrally, a lot of the time they just spit out to syslog, and the syslog server is wide open to anywhere, and so it's not that difficult to get on there also, or alternatively, send it a whole bunch of junk so that it just crashes. A lot of people don't watch the router logs either, so it's there. They just, unless something horrible happens and they're digging through, not so much. And a lot of them will only log access list failures and local events on the router. So if you do something like taking a unused local subnet and adding it, that's not going to show up in their logs. That's okay behavior, which, okay. So here's the tools slide. And there's a Perl script that the Russian guys who did the Hacking Cisco Networks Exposed book wrote so that you can actually speak EIGRP. And all these slides are going to be on the conference website, so you people frantically writing down don't have to write quite so frantically. There's Zebra Suite, which will allow you to speak OSPF. There's a tool called Yersinia, which will allow you to attack a lot of the layer 2 things, the hot standby router protocol, Cisco Discovery Protocol that we talked about. PhenoElite has written some pretty decent tools, and Cisco Torch, which was the brute forcer and vulnerability checker, sort of in quotes. It checks for 4 vulnerabilities, but it's a very young tool and is being developed. So I'm sure as they find more vulnerabilities, they'll add them in. There's CDP tools, which is available off of FreshMeat, and that allows you to live from a Unix box and speak CDP. And you can just say, hey, I'm a phone. No, wait, I'm a router. No, wait, I'm a switch. I'm a washing machine. Okay, there's no washing machine option, but you get the idea. And then you can brute force with Hydra or Nmap or AMAP. So that's most of the attack side. We're going to breeze through defense really quickly because it's 101 stuff. And then we will round up with what we need to look at next and where the active areas of research in backbone hacking are. So if you folks are pen testers, there aren't many people out there right now looking at this. It's more popular than it used to be because of Cisco Gate, but you guys totally have the skill set to work on this. And it makes a nice add-on to your pen test as long as you're upfront with the client about, hey, is this okay that we hit your infrastructure? We won't do denial of service if you're not cool with that, but you really need to get this checked out. And for people on the inside, it's often trivial. Like, when I was an ISP engineer, if I'd gone postal and gotten disgruntled, I could have wreaked a whole lot of damage. And there's very little protection against that. There's also a book out that specifically focuses on infrastructure stuff, and that came out like mid last year or so. I don't know how it's doing sale-wise, but I know I got my copy on like day 2. Okay, so if you're the defender, test stuff, design audit, make sure that you treat your infrastructure like important servers. They have to be subject to the same, do they need patching? Is this code recent? Do I need to do anything like it? Include them in your policy and incident response plans so that you're not completely blindsided if some person in Nigeria takes out your backbone. Talk with the ISP about security responsiveness, because a lot of the time, if you're the end user, there's not a lot you can do about a denial of service or something like that if your pipe is full. You need to make sure that if there is a backbone incident that you have support from your provider before things get really bad. Network people as area-specific contacts for whatever they're responsible for, log verbosely, log securely, and log all over the place and save it for a long time, log not just failures, and this should be included in the existing security policy. Check for leaking information, because a lot of people have no idea that they are advertising their backbone routing protocol passwords to the whole world. I got a couple of confused emails when we did that wireless project, and wrote people and said, hey, look, you really don't want to be doing this. They're like, how did you know? They just don't audit it, they don't check, and they don't realize that not setting external interfaces passive is going to mean that by default, in most cases, you will be speaking that protocol out of that interface. Use encryption when you can, use separate management networks when you can, use non-crappy encryption. So if you have the option of SSH2 versus SSH1, take the little teeny hit to your processor and do it. And if you have devices that don't support it, and you're in a position to pressure the vendor, yell at the vendor. Tell them, hey, we want SSH. We want something that we can manage this securely. Have you heard about what they're doing out there on the internet? It's bad. For your routing protocols in particular, for BGP, use MD5 authentication. That will save you from Paul Watson's windowing attack of like 2003, 2004 or so. It will save you from a lot of the nasty hijack stuff people do. The only bad thing about BGP MD5 auth is it has to be set simultaneously on both sides of a session. You can't set it on one side and then wait a couple of hours and set it on the other side and expect that to continue. So there is a bit of a syncing problem with your peers, but that's how it goes. It will make it a lot harder if you use authentication protocols and the best that's available for whatever protocol that you're speaking. It will make it a lot harder for me to come in with my little wireless router on a stick and cause you some problems. As far as backbone and stuff is concerned, unless we're talking like, point-to-point microwave links or something, wireless is just bad. Keep your access point far away from the middle of your infrastructure. You don't need everyone in a 2-block radius to see it. It's not just like not securing your data, it's actually advertising. It is screaming out to the world, hey, here's what I've got. And nobody bring up web. Protect your authentication servers. This is important. We talked about that. Choose good passwords. Defense in depth, IDS, blah, blah, blah. You guys know this. Oh, filter. Not just who can access your infrastructure devices, but also filter what you will allow people to speak to you. For example, Don't let anyone who is in the outside world announce 10net to you. That shouldn't be happening. Even worse, don't let them announce your net space to you. It's happened. It worked. Only announce your own net blocks out. Egress filtering will catch people on the inside of your network trying to do things they oughtn't to. If you are watching what you're advertising and I go and add in a subnet, you should be able to catch that. And it's worthwhile to think about bogon filtering. Bogons are net blocks that are not allocated to anyone yet. And it's another old trick to grab an unallocated net block and start speaking it and see who will take it. And a lot of the time it works because people just don't want to go through the pain of updating a list of unallocated net blocks every so often when one gets allocated. But if you can spare the management time, it's really worthwhile. Patch your software regularly when something bad happens, and also just, on your whatever your normal patch cycle is. It's important. I know it's a pain, but it needs to be done. There are some excellent templates for how to lock down your devices. These are the Secure Router and Secure BGP templates for both iOS and Juniper networks. You can follow the principles in them for other devices, but these actually give you command by command. Here is what to type in. Here is what you get. And they're very, very helpful. So if you only remember one slide, remember this slide if you're a network defender type. So if I'm crawling around on your backbone, how are you going to know? Uptime and availability issues are one of the first ones. If you see like a sudden reboot and you didn't reboot anything and you don't know of any problems, that might be worth checking out. If it's not an intruder, it's likely to be a problem. And either way, not very good. Sudden spikes in processor and memory are also common. A lot of the people who are out there hacking routers because they want to be a script kiddie and use it to packet someone off of IRC, you'll suddenly see the processor and the usage on that router go way, way up because they're using it to knock some noob off the internet. And if you're watching your monitoring software, you can pick this up. Also, vulnerability disclosures or vendor notifications, you'll often see a spike in scanning for whatever it is that just got announced. So if there's something that got announced on an infrastructure device, you might want to keep an eye out. All right. So new areas of research, things that I'm going to be looking at soon and I know other people are and that are worthwhile. Backbone and management cryptography implementation testing. Basically, the reason I haven't done this one in depth is that I don't have the, tens of thousands of dollars of gear. But a lot of the implementations out there, they'll take like a chunk of OpenSSL, but not the whole thing, and they'll implement parts of it, but not others. And I'm pretty sure that there are some decent crypto bugs that could fall out. Like even if you use just the University of Finland's SSL testing suite or something like that against a lot of these devices, I think you would find some interesting bugs. One of the things I'm working on now is fuzzing of backbone protocols. FX had a really just head-smashing bug about 6 months ago or so, where with one of the trunking protocols, if you send it a different version number in the packet, then it dies. The router has a denial of service. That should so be caught in basic QA. And the fact that that works means that there's a lot of other stuff out there with anomalous input that is also likely to work. Exploit code versus the devices, we talked about that already, and strong mutual authentication. Right now, a lot of these devices do not have good crypto stacks. There's no way they can exchange certificates and actually understand each other. It's just not there. So if you want to work in the development side rather than the breaking things side, that's something that's worth checking out. And if you come across a backbone, you've tried all this stuff, you don't know what to do, and you're trying to figure out what to do next, look at everywhere you can input data or change the state of something. Try and figure out which ones of those will be useful to you. Useful could be denial of service, could be authentication bypass, it could just be your web hack. And a lot of the bugs that you're finding in backbone stuff, they're not like I came up with this brand new theory of BGP and no one has ever thought about it the way that I did. Unless you're Paul Watson, that's relatively unlikely. Most of the bugs that are out there are things that are known in other arenas and just someone ported it to infrastructure. So I think that's pretty much all of it. I think we have like 3 minutes if anyone has quick questions before the end. Questions? I see I've stunned you into silence. or it's before noon.